All right, time to do an example of the oriented surfaces. So this is the same example that we did last time in our, let's see, with flux. But this time we're told which direction to use for our normal vector. And so here, the idea is that, well, last time I kind of spoiled the surprise. Last time when we did it, the normal vector that we found was pointing inward, so we're just going to do the opposite order of the cross product and we'll be fine. But let's pretend in a scenario we don't really know. So we can do the cross product of the unit tangent vectors, or of the tangent vectors. So tr cross t theta is equal to, and just as a reminder, this is minus r cosine theta and minus r sine theta and 0. Okay, so then let's say I don't know which direction the unit normal or the normal vector is pointing. So let's maybe just pick a random point. So let's see. Let's take x and then 1/2 and theta. So this is again r and 1/2 and theta, and I meant to put a 0 there. So we're at a distance of 1/2 at an angle of 0. So I don't know. Let's just say that's going to be like right there. Okay, so then if I put this into my parameterization, I find that I'm at the point 1/2, 0, 1/2. Okay, which, yeah, that's pretty good. So there we are on our cone. And then if I look at tr cross t theta at this particular point, so 1/2 and 0, what I end up with is minus 1/2, 0, and 1/2. Okay, so then that is telling me the direction of my normal vector, right? So then it's pointing the negative x and positive z. So it's pointing kind of in and up like that. Okay, so it's pointing into the cone. So this is an inward pointing normal for the unit for the tan or for by default. Okay, so then if we want the outward, so if I want the outward normal, then I simply just have to flip the directions. So it would be r cosine theta, r sine theta, and 0. Okay. And then with this, then I can then compute the flux of f dot ds. Okay, and this time I could just tell you it's going to be minus pi, but I'll just write it out. So it would be 0 to 2 pi, 0 to 1, and then 0, 0, 1, dotted with, and then our outward pointing normal. So r cosine theta, r sine theta, and oops, that shouldn't be 0. That should be a minus r. And I copied this down wrong from the beginning. That should be r as well. And then minus r. Okay, and then dr d theta. And you can compute this. And last time we saw with the out or inward pointing normal, we got pi, and then this just gives us minus pi. All right. So just an example with finding the flux when we're given a specific orientation. And again, the whole point of this little segment here was to help determine the direction of the normal vector that we compute automatically. Sometimes it'll give you inward, sometimes it'll give you outward. So it's a good strategy just to take a test point and check, and then adapt from there.